Welcome to the Building Digital micro conference on digital tools from data to sustainability, measuring and reducing carbon emissions in construction projects. I'm your host and chair today. My name's Joseph Broon. I'm the Managing Director of Building Digital. And we're joined today by three really interesting speakers talking about reducing carbon emissions on site and the technology there to support it. So we're going to kick off today's session with a presentation, first presentation from Andy Mitchell. Andy is the Operations Director and Responsibility Business Lead for Mace, who of course are a very well-known Tier 1 contractor. Andy will be talking about the challenge of carbon data management for a Tier 1 contractor and how hard is it to get data. So over to you, Andy.
Good morning, everyone, and thank you for this opportunity to talk to you. So yes, as the intro there, my name is Andrew Mitchell, and yeah, I work within Mace. Mace is a three-tier sort of organisation. So we've got the construction arm, which hopefully you'll be familiar with, especially if you're wandering around London, central London. We have a consultancy business as well. So I actually sit within the consultancy business within Responsible Business there, and we have an operate business. So we have a big spectrum of opportunities to understand what's going on out there in the built environment. But my responsibility is social value and environmental delivery into our construction engine, which is divided into 5 sectors. We do offices, private sector. We do a public sector division, which is obviously picking up quite a lot of government funded projects. A lot of the work is within central London, within London itself, but we do quite a bit of work for the university sectors. We have an interiors business, data centres, and aviation. So we've got big long-term contracts with Heathrow, Manchester Airport, etc. So that's kind of what we're doing. So my role is to ensure we're on top of our game in terms of responsible business, whether that's social value or the sustainability piece. And hence, I'm going to talk to you about carbon today, because that's the big piece. That's the big agenda which we're working to at the moment. So why do we talk about carbon? Why do we need carbon data? So as an organisation, Mace, we're quite aggressive in this area in terms of sustainability. The majority of our competitors and the majority of the industry out there talks around about goals to achieve certain standards by 2030. In our wisdom, Mace has taken a different stance. We're going for 2026 for most of our challenging targets. So we're up against it. It's only a few years away, as we know. So within our corporate target structure, we've got some key headline figures which we promote quite aggressively. So we are targeting by 2026 to save 10 million tonnes of client carbon. So that fundamentally means that when a client comes to us to a project, whether it's a construction project or a consultancy project, we are looking to add carbon savings on top of what they already perceive they can achieve. So it's quite an aggressive piece. We originally set this at 1 million tonnes, and we've already achieved that. So hence, the beginning of this year, we moved the goalpost a little bit further away, so we've pushed it up to 10 million tonnes. So obviously on the back of that, carbon data is key to what we are doing. Carbon data is key to us delivering those offers to our client base around the world, fundamentally in the consultancy business and in the UK within Construct. At the same time, we are year on year trying to reduce our active emissions, our scope 1, 2 and 3. That's through our site selection, site operations, and also obviously our fixed office spaces, etc. And then I've just added at the bottom there the science-based targets for buildings. Now this has come out at the beginning of the summer. The consultation came out then, and we're expecting it to be published around Christmas time. We have been waiting for this for some time. So for those on the call who are not familiar with science-based targets, basically that came out the back of the Paris Protocol, and it's a a strategy to ensure that a business operates within 1.5 degrees by 2030, etc. And it's a protocol which has been adopted globally, and we've been waiting for the specific building one to come out because we felt that was the most appropriate for our sector, and it gives us a framework to work on. Within that, there is quite aggressive carbon numbers. We're looking at understanding what our embodied and operational carbon numbers are for our projects. So they're not our buildings as such. We're a tier 1 contractor, so we're handing them over, but we have a responsibility as an influencer and a support mechanism to drive that carbon down on behalf of our clients and obviously for the wider environment. So yes, it's going to be quite a challenging piece when we get to Christmas and see what comes out of it. And then the second point there is client demand. You know, we are winning work on the back of our understanding of carbon. Our clients understand we are at the top of our game and being able to manage and reduce embodied and operational carbon. And it is an important piece for us. We are dealing with obviously people like Landsec, British Land, and then also government procurement buildings, universities, etc. So they're all aware of the climate emergency which we're in, and they're looking for us to support that process. So those are the two main reasons why carbon data is becoming increasingly important to us, and we need to understand what's going on. So, apologies, I didn't realize there's some animation on there. So what is, how do we go about this carbon analysis? How do we go about this carbon accounting? So really we break it down. This is the RICS definitions of how we define what carbon is in terms of within the built environment. And some of you may be familiar with this process on the call. So on the far left-hand side there, through the construction phase, obviously that's the phase of probably a reasonable amount of influence that we've got, Mace, at this point. You've got the embodied carbon of the materials that's going to end up on site. So you've got the extraction of the raw materials, you've got that transportation to the manufacturing facility, and then the bricks, the air source heat pump, etc. is manufactured. So that's the pure embodied carbon of what makes up our buildings, etc. And as you can see there, that's quite a high percentage for the total carbon journey for a building. Okay, 50% is an indicative value there. Then those products are then collected and taken to site, wherever that may be, and then we put them together. Mace puts them together on site to create that new building, that refurb, etc. So we move into that yellow section there. And again, that's relatively small, 5% of the total carbon journey for a given building. In this case, we're really pretty good at managing the on-site emissions. We're really good at managing our carbon liabilities on site. All our sites are on renewable energy. We ban diesel, etc. And we've got some processes at the moment where we're looking at getting the product to site, where we're encouraging non-diesel use, etc., and efficient ways of delivery. That mapped in with local procurement. So that traditionally has been the area of Mace's most influence. Obviously, we're in the ability to select materials, so we can look for low carbon products. And we're in the process at the moment of doing a really aggressive educational piece and requests for support into the supply chain on product selection. So we've gone out to them and requested, please issue us a low carbon product. Go to your networks and come back to us with a low carbon product, which we're now cataloging, and we can use as ammunition when we get a new bid in, etc., to support that carbon saving piece. Once the building is passed, once we've completed, we've got to practical completion, it then moves into the operational phase, the building in use, and that's that green section there. The big one there is replacement. So B4, as it's written down on the bottom there, Obviously, when parts come to the end of their natural life, heating systems, cooling systems, etc., then there's a big carbon liability there. So we do have an element of influence at this stage. We do have an opportunity there to advise the clients and drive this down. So the building is going to be used for 60 years, 90 years, etc. So this calculation, this whole life cycle carbon analysis is done over that whole period. So replacements come into it. So again, with our supply chain, with their support, if we can get that position sorted and get products with longer life, then that will help our total carbon piece. Additional to that is the operation of the building. So what we look at here is obviously how we heat, cool, etc., lighting and water consumption. So again, we have an element of influence here that, you know, we are a contractor, we're not a design house as such for the majority of our pieces, but because of our experience, we can make some educational support pieces into the design team. And again, some of you on the call may be familiar with sort of movements in operational energy. Neighbours is come to the UK. It's a operational energy standard that's come from Australia, and that is setting some quite high performance targets for us. And again, looking at the total percentage, the operational energy is really important for that life cycle of that building. Then we move on to end of life. So the building is completed its lifespan and it goes into a demo position. There's a demolition, etc. on site. That's relatively small. And then at the far end there is the circular economy. Now this is a piece which is the missing jigsaw in this sort of carbon landscape for the built environment. There is some reuse going on, but it's fairly limited at the moment. There's specific products, etc. So what we look at as Mace is we would do a calculation around this whole piece. We would look to build a model. We would want to understand what the total carbon liability is of that particular project for 60 years. And our clients will come to us with that number that they would like to hit. There's some standards out there, LETI, etc., that have defined what they believe is a good practice or best performing. And we as an organization, we as Mace have signed up to achieve certain numbers. We've signed up to achieve certain embodied carbon numbers for the life cycle of that building, that if we do better for our clients, there's some financial reward for us. If we do worse, then we get penalized. So it's becoming increasingly important. So the better we can do this process, the more data we can hang our hat on, the stronger our argument is and the stronger our offer is out there in the workplace. So what is the data we need? So really, it's not massively complicated. It's really, we want accurate volumes, material volumes. So that could come from a bill of materials, cost analysis, and also the BIM model. So we really just need to understand what the volumes of each of the elements are. And then on top of that, then we need to understand what the carbon data is for those products and materials we put together. So it sounds quite easy. It sounds quite straightforward. But the challenge for us is we want to do this at really early stages. We are pushing our clients and getting opportunities at RIBA 2, sometimes even before then. We're pushing the envelope in terms of, let us get involved, let us support you on this carbon journey. So we really want to be as early as possible in that design phase. And at that stage, there isn't really the data. Our BIM model is not going to be very accurate. The cost plan may be a little bit more useful at some points. And then on top of that, there is distinct challenges around carbon data in the industry. It's a new industry, and hence there's a big challenge there of whether the quality around what we can use in terms of specific numbers. There's no legislation around this in the UK at the moment. There's lots of talk. There's Part Z. There's some other pieces that come through Parliament. Some select committees have talked around this a lot. So there's no requirements for building regulations to understand what the total carbon of a building are. So as a result of that, there isn't really a defined framework that we need to work to. There's the RICS guide, and which is really useful, and the majority of us in the industry use. But on top of that, we just don't have that legislational framework sitting above it that gives us sort of confidence around some of the number crunching that we need to do. Hopefully that will make sense. So looking at the carbon data. So within each of these product ranges, whether it's a fire door, whether it's a carpet, whether it's an air source heat pump, a fire damper, etc., we want to understand what that carbon data is. And unfortunately, it's a new industry. We were talking to our supply chains, as I've already indicated, and sometimes we're pleasantly surprised and they're on top of it. Some sectors aren't particularly even aware of it's a need. Okay, so there's an educational piece out there into the industry, and I've just put up there sort of 3 sources of key data which we like to see. So the gold standard is an EPD, Environmental Performance Declaration. It's a robust analysis of a particular product or material, which has been verified, and it gives us an aggressive life cycle analysis in terms of carbon for that particular unit, whatever it is. Okay, some of the sectors are really strong at this point. So product manufacturers, if you're looking at insulation products, if you're looking at quite controlled elements that go into a building, plasterboard, etc., the majority will have an EPD. Okay, and that's what we want to use. That's what we ideally like. So that gives us some confidence that we're all talking about around the same metrics, the same carbon numbers. The one in the middle is a methodology which has been issued by CIBSE, and it's called TM65. Now, the MEP industry, mechanical and electrical industry, has arguably sat on its hands a little bit in this area in terms of carbon. And this is CIBSE's response to try and catch up, and it is welcomed. So it's and also when you think about mechanical kit that's going into the building, it's quite variable. So it's quite very difficult to generate an EPD for all the modules, all the variations that you can get in terms of specification. So it is quite a welcome structure. So in effect, it's a self-assessment methodology, which you go through for plants, etc., and it will generate a carbon number around it. There's some updates coming in the near future, and there's going to be some verification process going to go through with it as well. So they're up in their game. So that's very well welcomed. And then finally, there's the bronze standard, the one which the default position is. Our supply chain, the manufacturers, etc., come up with a definition of what they believe the carbon is, and that gives us some indication of where we sit. So ideally, that's not the route we want to take, but in certain sectors, it's the only opportunity we've got to get some degree of definition of what the carbon is going to look like. So what do we do with this data then? So the majority of the industry to date has been using a tool called OneClick. There are some other very similar software packages out there which support these calculations. So in effect, what we do is we do a whole life cycle carbon analysis for the building, and we take each building element and by line, we load it into the tool. We load into that the volumes or whatever metric is most appropriate. It may be volumes, it may be floor areas, etc. And then we select the appropriate carbon number from a database which is withheld within the tool. It's really time consuming. It's line by line. So generally what we've historically done is taken the cost plan, broken that down, isolated all the elements which we need to, and then load it into the tool. It is a good tool. It does what it says on the tin. It's been around for a few years now, but it is really time consuming. And the other challenge around it is when we don't have the material selection, when we're still at early stage, when we're at REBA 2, 3, etc., moving into 4, it's subjective to what the carbon number is you pick. Okay. So, it's not as robust as it possibly could be. And then Mace, we have got some really clever people involved around the business who are looking at specific elements. So we do quite a lot of work around the facades. We do a lot of work around structural concrete and steel. And then we'll have add-on calculations as well. So that would be a standalone piece. So it's a bit of a mix match. So I'm saying here we're using OneClick, but we use OneClick as a bit of a core. Then we suck in some other data from other specialist departments and then collate them. So what we do fundamentally is we collate them into a Power BI and it gives us an output for that particular job. So it is quite tricky in that respect. We are in the ability to do some analytical work after that, but the reality is it is quite cumbersome because of all this data entry which we go through. So hopefully that makes sense. So what does the future look like? So at the moment as I say, we're using that OneClick, and this is the position I'd like to get into, how we would like to run these calculations. So if you go from the top left there, so you've got material volumes and take that from the BIM or an estimating tool. So as the process develops, so we go from bid stage, so probably the estimating tool is probably the most accurate in terms of volumes of materials we're going to have on the job. And then ultimately what I perceive will possibly happen is we would then move across to the BIM model. As the BIM model becomes more accurate, as we get more data into it, and as we get more breakup of elements within the construction, we would then move across to those volumes. And from there, we would then map that data software to map the carbon against the material descriptions. Okay, so we have a database behind it. So we are in the process of talking with a estimating tool provider, and also we're talking to Autodesk in terms of Revit, in terms of what they can do, and we're looking at an opportunity to map that data set. So we could just take the model, it could read off those descriptions, it could then find the appropriate carbon number, and then generate a proper, a quick analytical tool, so we don't have to go through all that data entry. Then moving around to the sort of 4 o'clock position there, we then need a visualization and an analytical tool just to look at carbon concentrations and reference points. Because what we're trying to do here is obviously get to a position where we can quickly review the scheme, understand where the big carbon is, and then look for opportunities. Yeah, look for opportunities to drive that out, look for alternative material selections, etc. Then as we move around to the bottom there, now we're getting onto site. And what we want to be able to do is then take our site activity data, our carbon emissions associated with how we're running the site, and that needs to come into the calculation. We've got that data. We've got that data in other sources, and we just need to bring it through in an ideally an automated way. Then as we move up to sort of 8 o'clock position there, we then are starting to get materials coming on site. Okay, so the materials are coming on site. We know what those materials are, and then we should know what the carbon numbers are for those particular materials. And then we also know where they've come from. So we should be able to, then we should take the delivery distances and work out what those emissions are associated to. And that needs to feed back into the model. And then it's a continuous cycle. So what we're getting involved in now is a reporting period. So we are reporting every couple of months to our clients, saying what the carbon position is, whether it's gone up or down, and why it's gone up or down. So this needs to continue throughout the build process all the way until practical completion. We need to have a position where we can update the BIM model and it would automatically analyze the position of carbon, and we get that wash through. So we've got a continuous cycle of data updates, etc., which we're not able to do in an automated way at the moment. It's a completely manual process. So that's the kind of position we need to get to with the support of data sets which we've already really got. Okay, so I think that's fundamentally me. So hopefully that will give you some indication of what the carbon journey is and some of the challenges we've got around some of the data sets which we have got and which we haven't. Has anyone got any questions?
Thank you, Andy. That was a fantastic presentation, very informative, very comprehensive. and genuinely very interesting as well. Have we got any questions for Andy, please?
I was just listening to that. So now you're in a position to influence your clients and stuff like that. And you've got this very aggressive approach trying to knock down carbon. But do you ever find that you're getting ahead of the industry, of clients, of supply chain partners, of government bodies, of third-party bodies in the whole sector? Do you ever find you're getting a bit ahead of them, and you have to end up slowing down a bit?
Yes, there is a bit of that. I would, you are right. Clients are always different, as we all know. And sometimes clients may not be particularly interested in that carbon piece, but we will present it to them. And they may neglect to pick up on it. So, yeah, but we, for want of a better phrase, we pick our battles. So we know the pieces which we can do quite quickly and quite efficiently, and we've got a history of doing it. So, obviously the structural piece is fairly easy to do in terms of steels and concretes, and actually putting together a carbon offer and facades. So there is that, but the biggest piece around pushing it into the supply chain, and I mentioned this in the breakout room earlier, is obviously the challenge around education into our supply chain, and that we spend a lot of time doing that. So some of the guys are really on top of it. Some are coming up with some great offers for us to obviously support the industry, but some guys just don't really understand what we're talking about. So it is quite a varied piece. And again, it's also the same within Mace itself. There's 7,500 people across the business, and we are in the process of trying to get that educational piece across everyone, so that everyone can talk to a client and has a degree of confidence they can put a carbon and have a carbon conversation. And that's quite difficult to do. Everyone on our projects knows what the cost per square meter is of their project, but nobody really, we want everyone to know what their carbon number is, the kilograms of CO2 per square meter. So that's another big piece we're trying to push into it.
Excellent. Thank you. Thank you, Andy. We've got a question from Bill Dixon.
Oh, Andy, just a quick question in terms of capturing the data for carbon on site as you do the construction. How easy are you finding that to do?
We're fairly good, I would suggest. We're always looking for new opportunities. So we have developed a tool internally ourselves, and we are able to capture material movements onto site and obviously our energy consumption on site. We're quite good at setting up temporary supply and all that good stuff around metering. So we are fairly good. We've got some trials at the moment on some new technology. So I don't know if any of the guys on the call are familiar with Qflow. So we're having a look at that at the moment, which is quite a way of managing material onto site. And they've also got quite an aggressive carbon piece behind it. So we're looking at that. But yeah, it's just putting it all together in most cases. We've got bits of data there, and it's just trying to mesh them together, which we spend quite a lot of time doing.
Would it be fair to say that you're most of the time you're measuring sort of the fuel energy input side?
We're measuring that, but we also are looking at being able to measure what the embodied carbon is for that particular product that's come to site as well. We are also, as I've indicated, we're pushing our supply chain to give us offer of what their carbon numbers are looking like. But no, we're pretty good at that. We know what liquid fuel consumption is on all our sites. We know what the energy consumption is on all our sites. So there's some challenges around it. Sometimes it's higher than we want it to be, but no, we are pretty good at that.
We've got time for one last question. Thank you, Bill. Much appreciated for your question. We've got time for one last question, which is Bev Jones from the Career Colleges Trust. How do you pass the targets onto your supply chain, those that install?
Yes, a very good question, and it's not something we do very well at the moment because we haven't got the we haven't got the data aggressively enough at the right times. So the reality is, we work going back to structural steel and concrete. We are able to do that, so we will illustrate a target they need to achieve. Okay, so we will move that number down. We would like to do it more. You know, we would like to break up the complete packages. So when we go out to tender, we would like to give a carbon target down to those guys, and then obviously that would then wash up to what we're being tasked with by the client. We are able to do that on the structural piece at the moment, and our intention is to wash that down as we get better at the carbon accountancy piece. So yeah, so a really good story at the moment around a job right next to our headquarters, where the guys there, it's a structural steel frame, which has gone up, and you know they've actually bettered than what we asked them to do. So we are moving that down into the supply chain.
Brilliant. Thank you, Andy. And just please join me in saying thank you to Andy for a great presentation. Thank you, Andy.